27 minus x cubed. Descending order? No. Greatest common factor? No, but there is a negative leading coefficient. I have to address that first. So I pulled out -1. What do I have left in parentheses?
Cubed.
Right, but what do we write? We have to write something in parentheses now.
So that'd be x plus 7 or
so -1 times x cubed is negative x cubed, and -1 times -1 is 1/27. We factor out -1. Good. So now what is it? It's a binomial. And now I hope for a special product. What do you think it could be? What could it be? It cannot be the difference of squares because there is no square that is x cubed. So it can only be the difference of cubes. So I have to come up with a binomial and a trinomial. I will always start with a sequence of signs. If the binomial has negative, then I have negative. And of course, I have positive in the middle. And the last one, we never even discuss it. The last one is always positive. Okay, what do I do next? I need to identify the binomial. Once I identify the binomial, the trinomial is a piece of cake.
X minus 1/3.
X minus 1/3, excellent. I squared x and I put it here. I squared 1/3 and I put it here. And the product of the two is 1/3 x. This is easier. The second part, the trinomial, is easier than with a special product for binomial squared. Any questions? Any questions?
When you factor out the negative x cubed, then
no, I factor out -1.
Yeah, I meant when you factor that out, it just changes the
yes,
sign.
Because -1 times x cubed is negative x cubed, and -1 times -1, I have to recover what I started with.
Okay, I was just double checking.
Yes, this is very important. You will see later why. Any questions? Very good question. Anything else here? Anything else? Anything else? Okay, so let's look at other examples from Pearson this time. Okay, here it is. I'm sharing my screen. Let's take a look. It's such a mess. Such a mess. Okay. We're only looking at binomials. We'll come back and work on as many as possible, but let's practice a little bit with what they have, and then we move on to trinomials. I wanted to have the entire picture at once so you understand how important the categories are. So, and what's happening here? What is going on? Really? Oh, thank you. They just denied me. Okay, ready. Good. So this is our first example. 16x squared minus 25. Please do not skip the steps. It's in descending order. No greatest common factor. No negative leading coefficient. I identified it as being a binomial, and I'm hoping for a special product. How will I factor this?
4x plus 5, 4x minus 1.
Very good. This is the difference of squares. 4x plus 5, 4x minus 5. Again, 16x squared minus 25 is 4x plus 5, 4x minus 5. It doesn't matter how you write it. You can write it as 4x minus 5 times 4x plus 5 is the same thing. Good. Let's see what else we should practice with here in binomials. We have not talked about trinomials, so we're going to come back and look at trinomials. Okay, this is a good one. So 100 minus x squared. Please get used to, can I factor it like this? Yes, but please understand what follows requires you to present it in descending order first and factor out the negative leading coefficient. And then, so descending order, now yes. Greatest common factor, no. Negative leading coefficient, yes. I factor out -1. And now I hope for a special product. And this is a special product. It's not the difference of cubes, it's the difference of squares. And when I say difference of squares, I prepare plus and minus.
X plus 10, x minus 10.
That's it. X plus 10, x minus 10, or x minus 10 times x plus 10, the same thing. Any questions on this problem?
The factoring -1 makes it a lot easier.
Yes, yes. I don't know why they don't put it in there correctly. I have no idea. That's what I said. I was not ever able to follow any of the books, the factoring in any of the books. Aha, very good one. X squared minus 144x. Descending order, yes. Greatest common factor, yes. Again, I cannot stress enough. If you skip any of these steps, you're going to get yourself in trouble. Yes, there is a greatest common factor, which is, yes. What is left in parentheses?
X minus 144.
That's it. Linear factor, done. This is it. So this particular example was a binomial, was in descending order, greatest common factor, no special product. This is not a special product. This is a linear factor. Degree 1. You cannot factor degree 1. This is it. Degree 1. You cannot factor degree 1. This is it. So this is the only thing we can do to this binomial. Just factor out the greatest common factor. And it did not have a negative leading coefficient. I didn't have to factor out -x. Good. Moving on. Good. That's a good one. So 81 m to the 10th, although this is a little bit stretching it. It's really not necessary. But, okay. Good. Descending order? Yes. M to the 10th, N to the 6th, it's in descending order. M, N. M is first, N is second, and the power is 10, so that's okay. Greatest common factor? No. 81 and 16 don't have a common factor. Negative leading coefficient? No. Special product? Yes. Because the power is 10, I know it could only be the difference of squares. It cannot be the difference of cubes. There is nothing that I cube to get 81 or m to the 10th. There is no such thing. So, what can I get?
So 9m5.
9m to the 5th. 9m to the 5th. Very good.
4n2.
Because it has to be squared, it's to the 3rd. 4n to the 3rd. When I square this, I get this. When I square this, I get this. Again, this is a little bit stretching it. There is no need for something like this. Okay. Good. That's a good one. W squared minus 1 over 36. Descending order? Yes. Greatest common factor? No. Negative leading coefficient? No. What is it? Binomial. I'm hoping for a special product. But since it's 1 over 36, I could only think of a difference of squares. I could not think of a perfect cube, a difference of cubes. So, what do we expect?
W plus 1, 6.
That's
minus 1, 6.
Yes. First term squared minus second term squared. Because we know the special product from last week. First term squared minus second term squared. We can always check. Good. Moving on. Let's see what else is in here. This is, yep, let's also work on this. 36m squared minus 25 over 36. Good. Descending order, yes. Negative leading coefficient, no. Greatest common factor, no. This is not a difference of cubes. This is not a perfect cube. This is not a perfect cube. So if applicable, I will only think of the difference of squares. And what do I get?
6m plus 5, 6. And then the negative version of this.
6m minus 5 sixths. Why? First term squared is this, minus second term squared is this. Any questions? Okay. Okay, let's also look at this one, x squared minus 0.36. Let's see what else is in here. Okay, this is a good one. 3x squared minus 4 plus 5x squared minus 4. Although we did not really get to this step, but that's okay. Okay, also x squared plus 81y squared. Good. Okay, yes, very good. 9x squared minus 81. Good. Yes, very good. So I'm just gonna copy a few. You don't have to copy anything just yet. Okay, we'll come back. Okay, again, it starts to stretch it, but that's okay. Numbers don't have to be this large, but that's okay. 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 Okay, some situations which we do a lot of stuff. Okay, that's good enough. After we complete these binomials, we can move on to trinomials. Okay, so the next one in line is x squared minus 0.36. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. What is it? Binomial, that's all we discussed so far. So x squared cannot be a perfect cube. So I hope and expect a perfect square, difference of perfect squares. So then what do I get?
X plus 0.6, x minus 0.6.
X plus 0.6, x minus 0.6. Perfect. Excellent. First term squared minus second term squared. You can always take 5 seconds to verify what you wrote. This product, if this product does not equal this is incorrect. The left-hand side, I'm telling you, the left-hand side equals the right-hand side. It better be. Good. Now, I want to explain this one. Notice that this is still two terms. It doesn't really follow the pattern we discussed. Okay, so this is a little bit of an outlier. It doesn't really fit in what we are discussing, but it's a binomial, so to speak. So what I'm saying to you is that we have two terms. I'm looking at these two terms and I'm trying to identify if there are common factors or if there is a common factor. Do we see anything that is common in here and as well as in here? I need to pull that out.
X squared minus 4.
Indeed. So we have an x squared minus 4 in parentheses. From the first term, once I removed x squared minus 4, what is left?
3x.
3x. Then I have the plus sign. From the second term, once I remove x squared minus 4, what is left? 5. This is perfect. This is a linear factor. No one can factor that. But this can be factored, and it has to be. And it's the difference of squares, and I have to copy 3x plus 5. How do I factor x squared minus 4?
X plus 2, x minus 2.
X plus 2, x minus 2. So again, this problem didn't really fit. We're going to get to this a little bit later. So because I wanted to show it to you because it pertains to binomials. And this is what we're going to do next. Okay. Any questions so far? Okay. We're moving on to x squared plus 81y squared. Descending order, x and y, that's okay. Greatest common factor, no. Negative leading coefficient, no. Binomial, special product, yes. Which one?
Prime.
Prime, because it's the sum of squares. The sum of squares is not factorable using integers. Excellent. Next one, 9x squared minus 81. Descending order, yes. Greatest common factor, yes. And I have to pull it out.
That's 9.
9. What is left in parentheses?
X squared minus 9.
Which is way easier to handle. Binomial, no negative leading coefficient is the binomial. And I'm looking at this, and I know that this by now, easy to factor. It's a difference of squares, and I should just get it over with.
X plus 3, x minus 3.
And this is completely factored. So please remember, if you leave the 3 inside, you're making your life more difficult. And you may not be able to, you may not see that there's a common factor in there. So I cannot stress enough. Do not ever skip any of the steps that you see here. You will have a solid understanding of factoring if you do that, and you never make a mistake. Well, never is a big word. Okay. We're looking at 343 plus m cubed. I'm going to write it here. So, first of all, it's not in descending order. I will rearrange it as m cubed plus 343. It's in descending order now. No greatest common factor, no negative leading coefficient. It's a binomial, and obviously cannot be the sum of squares. It is the sum of cubes. So assuming that it is the case, I know that first of all the sequence of signs. If the sum sum of cubes have, in other words, it's a plus, then I have plus in the binomial, but I have to have minus in the middle of the trinomial. Of course, the last one is always positive. We don't even talk about it. I know what I cube to get m cubed. What do I cube to get m cubed?
7.
It has to be m, right? M cubed is, okay. So you said that this is 7. Okay, let me just show one thing. So with the graphing calculator, we will put, one option is, see here the cube root, so number 4, and you put 343 to take the cube root, and we get 7. Another, yes. So under math, you have number 4, the cube root, or you have number 5, whatever. But then you have to put in first 3, then go to math, and then choose 5, and then choose 343, and then you get the same thing. I never use this. I prefer 343 because I know the power is 1/3. We discussed that. The cube root is power 1/3. I never mess with the math key. Because the cube root is power 1/3. The square root is power 1/2. The fourth root is power 1/4. But you can use whatever you will decide. So then we know that this is 7. Now the pattern in the trinomial is a piece of cake. First term squared, second term squared, and the product of the two. This formula does not have a 2 in it. It's just the product of the first and the second. And that's it. Now let's look at the next one. 125 x to the third minus 216 y to the third. Descending order, no greatest common factor.